All right. Hello, everyone. Sorry, I'm a little late with this. Hopefully, you aren't waiting too long. 1.2.5, what can go in and what come out? What can come out? You have many characteristics that you can describe about graphs and functions using the questions that you began developing in lesson 121. You also have learned how to tell if a relationship is a function. Today, you will complete your focus on functions by describing the inputs and outputs of functions. That being said, today is one of the most confusing things that we've done up to this point. Once you get the hang of it, hopefully it works well, but it might take a little bit of work to just kind of catch on. So please make sure you're paying close attention to what we're doing. Now, we are skipping a couple problems. We're going straight to problem 172. It wouldn't be bad for you to look over it, problems that we've done before, just in case, or 171, but we're just going to move on. So 172, examine the relationship shown it right. And you see we've got the function machine right here with a function. Find f of -3, find f of 0, and find f of 2. All right, so if I plug in -3, then it becomes f of x, f of -3 equals 6 over -3 minus 3, okay? And -3 minus 3 becomes plus -1, so f of -3 is 6 over -6, which would be -1. So this is -1. Now, if f of 0, okay, if I've got 0, 0 minus 3 is -3, 6 divided by -3 is -2. And again, I'm doing it just kind of quickly. This is not ideally what I would want you to do. I want you to ideally write down the equation, the function, and actually plug in the values. But for the sake of time and just ease in this situation in my board, I don't have that information here, okay? On your paper, I expect you to write f of -3 equals -1, f of 0 is -2, and f of 2, well, you tell me what the answer is. So pause if you need to. Tell me what the answer is for f of 2. All right, when you replace 2 in there, 2 minus 1 is 2 minus 3 is -1, 6 divided by -1 is -6. So f of 2 is -6. Now, please find f of 3, letter B. Find f of 3. What happens? Well, when you plug in 3 here, you get 3 minus 3, and 3 minus 3 is 0, and 6 divided by 0 is, be careful here, guys. 6 divided by 0 is not possible. You cannot divide anything by 0. Now 0 divided by 6 is 0, but 6 divided by 0 cannot be done. Therefore, it does not work, okay? You cannot divide by 0. By 0. Therefore, there is no solution. I can write correctly here. There is no solution. And I expect to see this on your notes, of course. Are there any other inputs that cannot be evaluated by this function? In other words, are there any other values that x cannot be? Well, look at it. Think about it. Are there any other values that would not make this function work? So if x is 0 or if x is 3, this function cannot work. Are there any other points? Actually, there shouldn't be. There should not be any other points that don't make this work, just 3, because that's the only value that will make this denominator 0, which is the only point that will make this not work. Every other value should make it work okay. Moving on, letter D. Here's where it gets a little tricky here. The set or collection of numbers that can be used for x in a function and still get an output. Okay, so it has to be the points that could be plugged into x to get an output is called the domain of the function. The domain is a description or list of all the possible x values for the function. This would not be a bad definition to write down. The domain is a description or list of all the possible x values for the function. Trust me, you need to know that, so write it down. Domain, a description or list of all the possible x values for the function. Describe the domain of f of x equals 6 divided by x minus 3. Now, if this were class time, I would have you write this out and try to discuss it with your team. Because there is no team, I want you to pause the video here in just a second and try to figure out, what do you think? How do you think I can write what the domain is for this situation? Think about it. How could I describe it? What do you think the domain would be? And I want to write it as simply mathematically as possible. So I do want to write it mathematically, preferably not just in words, but I do want to try to figure out how to explain this, okay? When you're done, unpause it. All right, well, this one particular case is a little weird. Okay, so after I say all that, what could X be? Well, the domain, and you would put domain, all real numbers except what? Except X equals 3. So the domain in this case is all real numbers except 3, because it can be. It just can't be 3. And I say real numbers because, yes, there are some things that aren't called real numbers. They're called imaginary numbers. We will not get into that much, but just know, basically, all numbers, all real numbers, okay? What other types of functions have you looked at this far that have, in this course or in previous courses, that have limited domains? So possible X values. Can you think of any numbers or any functions or any families of functions that have limited domains? Well, how were they limited? One option would be to think of, well, let's go with a possible X values. Think of possible X values. Well, one of them is our inverse variation, right? Which gets closer and closer to the x-axis, but actually will never cross the x-axis. So on an inverse variation, this value right here, this line right here, which is called the asymptote, that line right there is a limited domain. It cannot be that, okay? Anything else? Any other problems that we've talked about this far that would have limited domains? Well, we're going to keep talking about some of those. We're going to talk about and focus on those values later on. You could also maybe mention quadratic functions, well, no, quadratic functions are fine. What about square root? Think of a square root, right? Has nothing over here, so they have limited domains. Now, look at the graph right there, problem 173. Is g of x a function? How can you tell? Is it a function? Yes, it is a function. How can you tell? Yes, because, and I love how some of you mentioned it in class, every input has only one output. Every input has only one output, so there is no input that has multiple outputs. Which x values have point on the graph? Which is the domain? So, what is the domain of g of x? Here's where we got to think about mathematically. What values of x do have values? Well, they start at 2 and they end at 4. Now, does it include 2 and does it include 4? Well, this filled in dot here means it does include 2 and 4. Therefore, here's how we mathematically want to show it, guys. Ready? When it has 2 endpoints, it stops here. It does not include anything off to this side. It does not include anything off to this side. So when it has a limited line right here, goes from this line to this line, has an endpoint, a starting point, and an endpoint, we put those numbers first. -2 and 4. And the x values are in between. Well, what can you tell me about x compared to -2? X has to be greater than -2. And how about x compared to 4? X has to be less than 4. So that is what we're looking for. Now, can it be equal to? Does it include 2 and 4? -2 and 4? We said it does. So how do I do that? -2 is less than or equal to x, which is less than or equal to 4. Okay? The domain. So domain, and then you can put like that. D is -2 is less than or equal to x, which is less than or equal to 4. And we're going to practice this a whole lot more when we get in class. What are the possible outputs for g of x? Ooh, okay. We're introducing a little bit more. What are the possible outputs of g of x? Not inputs, output. That is called the range. So the range are all the possible output values for a function. Well, range goes from, let's see, the lowest point seems to be here, the highest point seems to be here. So please pause the video and see if you can mathematically tell me what is the range in this situation. Got it? Go. All right, ready? Range, and my bad, we should have had this be a capital D and this be a capital R. That's just kind of the letters they picked, okay? So the range, it goes from, what's the lowest point? -1, highest point, +3. What letter goes in between? It is not X, it is Y. And Y has to be greater than. Does it include, let's erase this, does it include -1 and 3? Yes, it does. So -1 is less than or equal to Y, which is less than or equal to 3. See that? And again, we are going to practice this a little more. D, Ricky thinks that the range of g of x is -1, 0, 1, 2, and 3. Is he correct? Why or why not? What do you think? -1, 2, 3, or -1, 0, 1, 2, and 3. Is that the range? No, because if I just had points at those points, perhaps, but the fact that I connected the points means it includes every value in between. So you can go at any point along here, and that does not just have to be the whole values, right? And that is it for today. We will finish discussing this tomorrow. We will practice this some more tomorrow because there's a whole lot more to this to go, but just so you know that. And I decided I'm going to just put, I'm going to try to remember to put the Foxtrot at the end of the video. That way, if you want to see it, you can just pause it, pause the video now, and read it. If you don't want to read it, you can just close the video out, okay? All right, have a great day, and I'll see you later.